Let's discuss about sets. Uh, let's consider number line 0, 1, 2, and so on. I'll consider three type of numbers basically. This number 0.33333 and dot dot, and another number 0.5 and another number I'm going to take from here 1.4142135 623 dot dot dot. Actually, I wrote three sets of numbers. When you look at this one, this number, uh, we call this number has just one decimal. As a result, we call this one, it has a terminating decimals. When you look at the second number, you can see actually I put three dots. Three dots mean it is going up to infinity, and you can see that 3 is recurring. So then this set is called recurring decimals. Three is recurring. So if I wrote 0.2525 dot dot dot, it's you can see that 25 is recurring. In here you can see this is also going forever, but in this type of numbers you can't find a pattern or recurring decimal. Next time 4, then next time 2. Likewise, we don't know what number is going to get. Actually, we know that we can find, but there's no pattern or recurring decimal. So those type of number sets called surds. So basically, we can divide the number line into surds and others are non-surds. This is actually square root 2. Some other surds are square root 3, square root 5, square root 7. You can't find the pattern on those numbers, decimal patterns. And this is where we can introduce rational and irrational. This 0.5 I can write as half. This 0.33 I can write as 1 over 3. But unfortunately this square root 2 we can't write as a fraction. So you can see that 0.5 as a fraction. Well, this class we can write as a fraction, but unfortunately this class, the third class, we can't write as a fraction. So if we can write any number as a fraction, we call those rationals. And if we can't write any set of numbers, then as a fraction, then we call these irrational. So this is the relationship between surd and the irrationals. Rational numbers usually we define any number if we can write P over Q form, then that number is a rational number. So in here, P has to be an integer and Q should be a integer. P is a member of element of a member of integer. Q is an element or member of integer. And Q should not be equal to 0. If a number satisfies this condition, uh, then we call that number is a rational number. Make sure that um, Q can't be a 0, because we know that any number divided by 0 is making infinity. So O 5 over 0 is infinity, and in other way, when I 5 and 0 times, to get 5, which number I have to multiply with 0, or to get with 0, which number I have to multiply to get 0 with 0, get 5 with 0. So as a result, we can't, if Q is equal to 0, then we can't define, the fraction is not defined basically. Do you think that 2 is a rational or irrational? 2 is a rational number because we can write 2 as 2 over 1. It means 2 is an integer of z and 1 is an integer of z, and 1 not equal to 0. But square root 2, you can't write P over Q form. So rules, there are two rules. If we see that a times b, square root ab basically, we can write as square root a times square root b. This will imply if there is a, b, c, d square root, then you can write a times b times c times d. I can show you from here. A, B, C, D. I will apply 2 times this rule. So AB times square root AB times square root CD, and then again I apply the same rule to here. So as a result, square root AB, and the same this rule to here, square root A times square root D. Also, the next rule is we have square root A over B. You can write square root A over square root B. So if we have A, B, C, C, D square root, then you can write A, B, C, D. You can switch as well, B, A, D, C. I can show you that A, B, C, D square root. So I'll use this rule first, then I can bring into this form. So I break using this form. Then from the previous rule, if we see this one, we can write square root A times square root B and square root times square root B. Simplify square root 21. So the only way we can write this one, 3 times 7. That's all, and square root 2 times square root 7. Actually, this is not a simplification. If we consider square root 2, 20, then yes, we can simplify this one, because simplifying means always we trying to write those type of numbers with aid of square numbers. I can write this one 4 times 5. Then I can write square root 4 times square root 5. Square root 4, we know that this is 2 and this is square root 5. So now we simplified this one. So basically simplifying mean we try to write the number with the aid of a square number, because we know that a square number we can square root the number. Square number we can be square rooted to get to a integer.